Hey, how's it going? This is Mr. Hernandez, and I'm going to go over another type of way that you can be asked to find percentages using the normal curve distribution. So the first one I wanted to go over was if they just mention, you know, standard deviations, um, let's say below and above the mean. Um, and so it's basically using the notation where the mean would be this is the mean is mu. Remember, it's that symbol that stands for mean. But instead of giving us a number, it's telling us standard deviation. So I'm going to use sigma for the standard deviation. That's one standard deviation. This is two standard deviation, three standard deviation. And then this is two standard deviations below the mean, three standard deviations below the mean, which is to the left of the mean. So in this case, it's talking about one standard deviation below and one standard deviation above for number one. So here's one standard deviation below, and I'm going to mark that off. Here's one standard deviation above, and I'm going to mark that off. And so everything would be between those two, right? Because that's the key word, between. And that's the part that I'm going to shade in. So that's 64%. So that'll be the first answer. So it'll be 64%. So if they talked about two standard deviations below and two standard deviations above, well, then you're gonna instead of marking it off here, you would instead make that red line at the 2 instead. So if this is like two standard below and two standard above, well, now you're going to be adding up a little bit more, right? In addition to the 34%, you're going to add these two. And that would be, if they would change it to, two standard below and two standard above. And the same thing for, three standard above and three standard below. Well, we'll get into that more. So let's look at another example. So this one says more than the mean for number 2. More than the mean. Well, the mean is right in the middle. So let me, so here's the mean right here, and it says more than the mean. So I'm going to basically make this our boundary, and more than is everything to the right. So that's all this here, all these numbers. Now we can add all these numbers individually, 34 plus 13.5% plus 2.35 plus 0.15%. But, you can kind of say, well, this entire normal curve is 100% of all the population. So if we cut this in half, which is at the mean, then everything to the right of this is going to be half of 100%, which is 50%. So that would be whether it's above, more than, or below, less than the mean, it's going to be 50%, because that's the boundary line. That's right in half. Okay, so this third one is going to be the most interesting, because you have a combination here. So two standard deviations below and one standard deviation above the mean. And it is between, so we are going to be shading in an area between these two. So let's see, two standard below. So let's just kind of, all right, here's the mean, here's one standard deviation below, here's two standard deviations below the mean, and that's our first boundary. Two standard below, and then one standard deviation above the mean. Well, that's going to be going to the right of the mean, and that's this one standard deviation above. And so these are our two boundaries, and I'm going to shade these in. And knowing that the 34 and 34 add up to 68%, that's what this bottom's for. You could add them up individually, but I know that these two are going to be 68% here, and plus this extra one, 13.5%. So I'm just going to show you how. So that's basically going to be, let me see, 68, 78, 79, 80, 81. So that's 81.5%. That for this area here. Okay, and that's it.